Hey and welcome back to a new video. About a year ago, we reviewed the Corsair One i500 pre-built, which was not only very expensive, but it also performed poorly. Now I figured out that Corsair is offering the Corsair One i600, its predecessor. And I also noticed that Corsair stopped heavily marketing this pre-built because last year they were basically shipping out the i500 to every reviewer, which seems not to be the case anymore. So I thought, okay, let's go ahead and just buy this system for 5,000 euros, that is including a 285K and an RTX 5080. So they definitely didn't fix the price part, but I hope they fixed all the cooling and performance issues. And that's what I want to review in today's video. Thermal Grizzly Duronaut is our new high-end thermal paste and the successor of Cryonaut. It's even better performing, it is much easier to apply, it is cheaper, and it's much more durable. That's where the name comes from. Especially if you're now maybe considering to buy a new PC, then I would highly recommend that you're looking into this thermal paste. So let's continue with this video. The Corsair One i500 from last year had a pretty questionable cooling concept, because not only was the 14900K only equipped with a 120mm radiator or AIO, it was also equipped with slim fans. That was, from my point, one of the biggest failures or mistakes in the i500, because there was space for normal sized fans, but they decided to go for slim fans, which had a pretty bad impact on noise levels and also especially the temperature. And I hope that they fixed it with this system. There were also further issues like the fan being in the wrong place and fan curves not being configured correctly, stuff like that, but you can just watch the video from last year if you want to. It's also pretty cool that Jay from Jay's 2 Cents had exactly the same idea, because he also reviewed the system last year. He also did multiple videos about his i500 and he was also not so happy about it. So I think from what I could see, because I didn't watch his video yet, but from what I could see from the title and thumbnail, he seemed not to be fully convinced by the i600, but I didn't want to influence my own opinion or the testing of the i600, so I decided to not watch his video yet. I will watch it straight when I'm done with my testing to see if I missed anything, but it's probably also a good idea to watch his video. The i600 is available in 3 different versions. It's also heavier than you might expect. But similar to last year, there is also a version that comes with a wooden panel in the front. I think there's 3 options in total. So like a light wood, a dark wood, and this metallic, just aluminum style front panel. I just visually liked this one the most, that's why I picked it. In this system, we have an Intel 285K, an RTX 5080, 64GB of DDR5, and 4TB of SSD storage. On Corsair's website, I can find the details about the components, but not as much as I wanted to. Because, for example, on top, when you look at the summary of the components, I can see that it lists 4TB of SSD storage. But if I go to details, I can see that it's 2 individual SSDs with 2TB each. Especially at the price of 5,000 euros, I would personally like to know what kind of SSD is built in. Like, is it Gen 3, Gen 4, Gen 5? And what kind of read and write speeds are to be expected. So that's what I would like to know. Also, I'm lacking a bit of information about the motherboard because it's only listing Z890 and that's it, no more information. As far as I know, Corsair is not yet making their own motherboards, so I guess they're using, I don't know, like an Asus or MSI Gigabyte OEM, something like this. And I also couldn't find any more drivers to download, which might be something useful. I guess they will use Corsair's iQ environment for the driver installation. But I don't know yet because I didn't start the system up yet. At this point, I just unpacked it, put it on the table, we're talking about it. I'm just taking you with me with my full experience. But that's just all I observed so far. And before we even get to the testing, I just want to talk about the price real quick. For this i600, as I said, I paid 5,000 euros. If I configure a similar style system or similar type system in Geizhals, I'm getting to a price of about 2,900 euros just for the components. But obviously it's also difficult to compare just raw components with a pre-built system that also has a special case that you can't buy. Somebody has to assemble it and test it and everything. So it's not that fair as a comparison. So I think it's maybe easier to just compare this to other systems from other system integrators. This is Duronaut. It's one of the most famous and biggest ones in Germany. And here I could find systems that are not only cheaper, but also a lot better. So for example, this one comes with a 9950X 3D, so that's the better CPU, and also the much better GPU with the RTX 5090. And it costs only 4,700 euros. And of course, the system I showed you from Duronaut is using normal components, so it's not using a special case. So there's still that argument, but honestly, with the price difference, I don't really see it. And also, the case itself might not be a good part. Like, you could argue it's a special case, it's more expensive, but I think also with this type of case, it might be more limiting in what you're getting, especially if you're thinking about upgrading. You're limiting yourself, you're dedicating yourself just to this case. And we know from previous year, from testing the i500, that it can also be a negative aspect to be limited to a special like style or type of case. There's one kind of funny aspect about this that I remember from last year because it was so obscure to me that I remembered it. When they sent me the i500, everything was branded to be sustainable. The PC has to be sustainable. There was like sustainable wood in the front and the packaging was special. I remember especially the packaging aspect because there was this marketing slide that was promoting this packaging foam made from like 30% oyster material. And I was like, what the hell is like oyster foam? I could almost find no information back then about it, but I just remembered it because it was kind of so special. But what I noticed now is that the foam, I'm not sure, maybe this is still some kind of oyster foam. I'm not a foam expert, so don't quote me on that, but at least it's fully different. It's not the same type of foam, and they're not advertising anything anymore about sustainability. And that's also, you know, it's this typical thing for me that big companies, they're like, oh yeah, sustainability, it's now a hype topic, we have to do something sustainable. Our PC is now sustainable, so we just do something special. But it's not really the company itself, right? Like, PC companies are usually not sustainable. That's just the truth. So you should not fall for these kind of marketing claims. One thing I saw with this system is that they are claiming recycled aluminum case, but I'm not quite sure if they're meaning 100% recycled aluminum case, which might be special then, but I can tell you that most of the time, any aluminum you're using these days is recycled to a certain degree, because it's a material that is really good for recycling. You can recycle everything about aluminum and just reuse it. So most of the time these days, if you're getting any product that's made from aluminum, a lot of this is often recycled even though you don't know about it. So they would definitely have to provide more information about it, but yeah, those sustainable and recycling claims are usually not a big fan of that. To be fair though, the packaging is still better than some of the other stuff that I know, because it's not using this like black glossy print on all this cardboard. So definitely the stuff is easier to recycle. As I said, not sure about the foam part, but it also comes in this bag, which I think is just better than packing this in the typical like plastic bags. We're now powering up the system for the first time. One thing I just have to highlight, because it's the impression I'm getting, is that the case still has a very high quality impression. It's a huge amount of aluminum, like thick pieces of aluminum on the side, and also this massive aluminum piece on the top. But let's just power it on. I can definitely hear the pumps of the AIOs, like just pulling air for the first time. That's fine. Just have to probably wait a couple of minutes until the air is going out of the systems. On the first startup, everything went smooth, and I just spent all the time setting up Windows, installing all the tools that I need. And now we can also observe all the system specs. We have the 285K. We can now also figure out that it's an Asus Prime Z890M plus a Wi-Fi motherboard. We have a 64GB of DDR5 with 6400 megatransfers as advertised, and the Palit RTX 5080. It was a bit unclear to me what kind of SSDs are in the system, but we can now see that the first one is a Corsair MP700 Elite, and the second one is a Corsair MP600 Core XT. This means we have one Gen 4 and one Gen 5 NVMe drive in the system, and what I also just noticed in hardware info is that the temperature, at least of one of the drives, is a bit concerning. The main SSD is the MP700, which is the drive C, and D is the MP600, and this one is... the idle temperature is pretty high, to be honest, and also 55 peak, considering that I didn't do anything with this drive. Yeah, you can see, like here, the highest read or write activity is like nothing, and it's still peak 55. That is already concerning. This means we will just perform Crystal Disk Mark to test its performance and also the temperature under load, to just the base test, D drive, 3 sequential read-writes, and then just see what happens. So on read, we can see above 5000 megabyte per second, but we can also see that it's straight getting warm. We can also monitor the actual read or like write speed in hardware info. Now it's taking the break, going over to the write test, and 5000 at first is good. But we can also immediately see that on the second and third attempt, it drops down to like 3000 megabyte per second because it's getting too warm. It's hitting above 80 degrees Celsius, throttling, so it can't maintain its speed. So I'm just repeating this again with just 9 times, so we have a little more time also to monitor this to see how fast it drops down. So it's performing 9 times read and then 9 times write, but you can already see after it's not even 10 seconds, not even 10 seconds, and the read rate is now dropping to half its speed because the SSD is getting so incredibly warm. That's quite insane, to be honest, because it's not even 10 seconds. The SSD, the second SSD, is basically, you can't use it. It's completely useless, and you have to keep in mind that this is sitting in idle. I haven't been doing anything with this system yet. It's like cold. This is, I don't know, like 30 degrees, the CPU is doing nothing, the GPU is doing nothing, so it's not adding any heat to the system. It was just pure SSD load, and it can't effectively handle anything. At this point, I'm not sure because I didn't open it yet. Did they just not cool the second SSD at all? Because it's a Gen 4 drive, consumed quite a bit of power. They need cooling, but it seems like there's like no cooling at all. We will see that later, but right now, I don't get it. Like Corsair is making SSDs, they should know that SSDs get hot and need cooling. Yeah. But we will continue testing. So for now, Cinebench R23 to check CPU performance and thermals. With a 285K running the default Intel profile, which is PL1, PL2, 250 watts, so that should be all right. So I guess, yeah, CPU package power is basically kept at 250 watts. That makes sense. Temperature looks okay. We should expect like 41,000 points, 41,200. So that is absolutely in line when it comes to performance. Thermals are okay with 82 degrees Celsius peak, at least for a single run. In the gaming scenario, this looks quite okay. We have the 285K, typically between 40 and 50 degrees Celsius with a 70 degrees Celsius peak on P-Core 22. But it's kind of expected with the 285K just pulling between 50 and like 60 watts under load. So it's quite efficient in the gaming scenario. And if we go over to the GPU, we also see, I would say, quite good temperatures. 63, 64 degrees Celsius underload on the GPU, 72 on the memory, so that's kind of expected with the 5080 pulling about 300 watts in a gaming scenario. I want to highlight that Corsair definitely worked on the noise levels that were an issue with the previous i500, but now this is like full load. And I'm standing like really close to it, and at least for me, it's in an acceptable noise range. I would say that's quite okay. It won't get much better with the CPU and the GPU being under load. Only in idle, the fans are sometimes ramping up and down a little bit too much. That could be improved, but overall I would say the noise level is a lot better than in the previous version. Especially with the previous i500 using a 4900K and only a 120 AIO, the thermals were not great. So what I want to test now is just what happens like in a render scenario when the CPU is under high load. Can the 240mm AIO keep the 285K under control? And this doesn't look too promising, to be honest. It's just 5 minutes and it's already starting to thermal throttle. So one of the cores, you can see right here, already hit like 96 degrees Celsius. They definitely improved it over the previous version because there I think we couldn't even run a single Cinebench run and it would straight throttle. Here at least 4 minutes, but also you have to keep in mind from the cooling concept, I can feel the system pulling in the air to the side right here. I assume the GPU AIO is behind this, pulling in the air, and then the hot air is like exhaust on top. And right now we only put load on the CPU. So there was no hot air introduced over the GPU. Now imagine you're running some kind of a professional application where both CPU and GPU are loaded. Then the GPU is putting hot air into the system. The CPU AIO will get then hot air for cooling, which will make the CPU throttle even earlier and even heavier. So yeah, the cooling concept is still not a highlight. I mentioned earlier that I didn't find anything where I could download drivers, so I thought maybe there's some functionality in the Corsair One dashboard. There is no IQ on this, so there's only this software, which is an improved one over the previous one. You can adjust RGB, for example, for the small RGB strip in front. Also, when you go to cooling, you can adjust the cooling if you wanted to. I left it in balanced mode, which is the standard mode they're shipping this with, but there's also the advanced mode where you can configure stuff yourself if you wanted to. There's this kind of documentation that you can access over the Corsair One software, and there it says that I'm supposed to find the drivers online on the Corsair.com product support page. Especially with pre-builds, it's just important for me that the customer can get access to drivers and especially BIOS updates, because often there's like some vulnerability and then the customer has to update BIOS and has to find it. So I thought, okay, if we can't find it online, then we just contact the customer support. Because further down on the German product page, Corsair is advertising lifetime technical support around the clock by the first-class customer support team by Corsair. So I started messaging the support, which I think in this case is just a bot. I asked where I can download the mainboard driver for the i600, and the bot asked me then to check the motherboard that I have, for example B660 or it could be C790. I then replied that the i600 is using Z890 and not Z790 or B660. And as a reminder, I just put Z890 there because that's all I could find on the technical details on the product page. So then the bot asked me to contact the technical support. I then submitted a ticket, received a reply where I was asked to detail the part number of this thing, which is interesting because there is only one version of the i600. I mean, there's the wood panel and like the metal panel, but in general, it's like the hardware specs should be the same. I then replied that I didn't have the system next to me, so I just sent in my invoice. The invoice is detailing the part number and also all the specs. I think it's not detailing the motherboard exactly, but it's detailing C890. So yeah, that's 2 days ago. I'm still waiting for the reply. Let's see. So while we're waiting for the reply, I think we can use the time, open the system and check how it's built. The side panel is made from some sort of fabric. In general, it's plastic, but covered with some fabric and a lot of magnets, which allow it to easily attach this, detach this. I think that's quite nice. Also for cleaning, if you want to, because it's kind of like a dust filter as well, and if you want to clean it, it's very convenient, I think. And there we find 2 screws, and I think if we remove them, we can take off the side panel. Side panel is massive. It's a huge and thick piece of aluminum. That's already what I appreciated last time. This is very well built. That is definitely different to last time. We not only have a different AIO, so previously there was only a 120 here and slim fans. Now it's normal size fans, 240 AIO, also 120 normal size fan on the bottom. It's not relevant, but I'm just getting question marks in my head because I see threads in this plastic fan, like right here. It indicates that at some point there was a screw in here for whatever reason. Maybe it was first assembled wrong. I don't know. Weird. I'm not sure why there is something sealed, but we're opening it. The system is featuring a custom-made AIO. Otherwise, the tubing would probably exit here or on the left, but I assume if you would use a standard 240 AIO, then the radiator would be a little bit too long. So I think they had to make this like custom design with the tubing exiting on the bottom. So it's like a custom-made AIO just for this system. And I already also spotted the MP700 on the bottom right here. So that's the main SSD. And also we can see the Prime Z890M Plus Wi-Fi motherboard. So here again with some sort of a seal sticker. I guess we're continuing here. So interesting detail, this like fan shroud right here has some kind of, I don't know, blades on the back for targeting the airflow more towards the left of the GPU. I'm just removing the AIO quickly to be able to access the GPU a bit better, and we can also check thermal paste, for example. That looks good, nothing to complain about, but I also can't take it out, still attached to the cable. I want to get the GPU out. I think this looks really interesting with a heatsink on this. Should be different from last time, might be better also in terms of thermals. I mean, the thermals were good. And talking about thermals, I think there was a small mistake from my side earlier. When we were testing the CPU with Cinebench, I was talking about like hot air exhaust on top, but it's the GPU that is sitting on top and the CPU that is sitting on the side. So the CPU temps would not be influenced if the GPU was also running. It's more like if the CPU is running under very high stress, the GPU would get warmer. This GPU is actually really cool. They put some thought into this, which I absolutely appreciate, especially compared to last time. There is this block on the right side, like this fin stack. We have two heat pipes going in there, and this is cooling the memory. Like we see the heat pipes going to the memory here, and it's all, if you check on the bottom, it's all one big cooling plate that seems to be cooling the memory. So I think the AIO is really just exclusively doing the GPU, and then this fin stack on the right is doing the memory. And then on the left, here, we see there's also a big copper bar, which is contacting the power stages, the MOSFETs. And then I think the MOSFET power is dissipated through this like aluminum plate all over here and also over the back. And they definitely added like thermal pads to everything. So they put a lot of thoughts into this GPU design, which I think is really cool. And this leads me towards the SSD sitting in here. Which makes me think, yeah, what is going on? That's kind of fascinating because somebody put a lot of effort and thoughts into the GPU cooling with all what we've just seen. But then we have this, which is probably also targeted towards the GPU cooling with directing the airflow. And this is also directing the airflow completely away from the SSD that is probably sitting somewhere here. And I also checked there is sufficient space for having a heatsink on the SSD. And Corsair has SSDs with heatsink. The mainboard doesn't have any heatsink built in, like most motherboards these days have, but this is like a rather cheap motherboard. Doesn't allow any kind of like built-in NVMe cooling, so they should use an SSD that includes a heatsink. Yeah, it's kind of weird. But in this state, with like no airflow on the SSD and no heatsink, we get what we saw with 10 seconds under load, the SSD just overheating. Now last thing is removing the aluminum lid, the top part, which is I think exactly the same part as last time. It's a massive aluminum piece. I don't even want to know what the cost is of making something like this. I'm partially not surprised why the system costs so much. And here we have, I would say, normal 240 AIO with the fans directed upwards with a, just exhaust. I will now take out the SSD and add a cooler to it. Luckily, I still have a couple of these laying around from doing all my SSD cooler videos, and I guess that should work. It's now pretty tall with that heatsink, but I think there is actually space for that. And it's already back in the system. I just have to put the GPU back in. And it fits without any issues. Even a much taller heatsink would still have fit. I'm almost done now with reassembling the system. I just want to also show the backside of the system just to cover everything. It's a pretty tidy and well-organized cable management. I have nothing to complain here. I can straight tell a big difference because previously in idle I saw like 40 to 50 degrees Celsius and now it's like peak 25. So we just performed the same test again as previously, just a sequential read-write 3 times. It is now performing as expected. Read rate is up, write rate is up, and look at it at the temperature. We just finished 3 times read and write. Previously we had straight 82 degrees Celsius, SSD was throttling. Now we have the expected performance and peak temperature 45. And now again I'm doing the 9 tests and we will see where we end up at. And even after the longer test, which is almost over, it's like 53 degrees Celsius now. So that's how it should look like. Time for the conclusion. And at least it's better than last year's i500, which was thermally a complete disaster. At least Corsair improved it. But that's basically it. If you would buy this for gaming, it would definitely work. If there was just a load mainly on the GPU and not on the CPU, you would have an experience which is okay. The thermals are okay in the gaming, and also the noise level is much better than in the previous year and is absolutely acceptable in the gaming scenario. However, whenever you're switching to a more intense workload, that could just be rendering a video, you will straight run into the limitation of this system. Which is interesting, because if you check online, then Corsair is advertising brilliant performance and a marvel of engineering. I'm not sure if a marvel of engineering is when you didn't even test your second SSD, because that's the only way how this can happen, you know? When I'm reviewing a system, it's pretty simple. I have the main components in there and I just have to test each one individually. So for example, what I didn't show is that I was obviously also testing 3D Mark for the GPU, but the performance was exactly where it was expected, so that's great. Then testing the CPU with Cinebench and then testing it long-term with Cinebench, where we saw that after like 4 minutes, the CPU starts to throttle because the thermal solution for the CPU is not big enough if you want to do anything other than gaming. So for any like render workload, the 240 AIO is just not enough for dissipating 250 watts. And if you approach the system exactly this way, you will also get to the SSD. And if you just run Crystal Disk Mic a single time, you will see that, the performance is somehow not in the expected range. It should be at like 5000 megabyte per second, but it's only reaching like 3000 or 2000 megabyte per second. What's going on here? Then you check the temperature, you realize the SSD is just overheating, throttling, and thus you're losing performance. So that's what I would expect. That's how I figured it out as well. And I can tell you it's not only sequential read-write. I, for example, also just tried copying a huge amount of files on the SSD itself, and already that is enough for the SSD to throttle because it's just thermally completely on the limit. And that's, at least to me, that's not a marvel of engineering. Especially the system being a pre-built, I would expect that you somehow have a page, a support page where you can find drivers or at least detailed information of the components such as the SSD or also the mainboard. Because right now, like 3 days later after contacting the Corsair support, I still have no information which motherboard I actually have. Obviously, I know how to figure that out, but a customer who's just buying a pre-built might not know about that. And he would need help or at least know details where he can find the motherboard driver. That is currently completely missing for me. And especially, I'm not sure how it is on like the English page, but on the German Corsair page, they are advertising support around the clock. And support around the clock, and after 3 days, I still don't know where to get my motherboard driver. It's not really that great. And that's mainly because of the price. You know, if this was a super cheap system, I would be okay with most of the issues, but you're paying over 2,000 euros premium and you're not getting a premium experience and a premium performance, which I think is the biggest problem of the system. And that's mainly also caused by the case and by the case design. Obviously, they wanted to have a special case. They wanted to have a compact case, and with above 20 liters, it's not big, but it's also not super small. You know, in the SFF community, I guess this would not be considered an SFF build. But still, this case design and what it is kind of limiting what you can do with it, and also like the thermals, for example. As I said before, with the 240 radiator for the 285K, it's just not sufficient to constantly dissipate the 250 watts, and that's why you're seeing what I saw, that after like 4 minutes you just run into the thermal throttling, and that together, like paying 2,000 euro premium, it's not a nice experience. So yeah, all right. Thanks for your supporting these kind of videos, because obviously buying a system for 5,000 euros, I'm never getting that money back over a single video. So that's kind of the financial mistake type of video, but I think it's important and it's only possible because of your support. So thanks for watching my video. Thanks for tuning in. See you next time. Bye-bye.